Hello, everyone. Good morning. My name is Angelika Gremska, and I work as a staff data steward at Bayer Crop Science. Crop Science is Bayer division that focuses on agricultural innovation. We develop and produce seeds, crop protection solutions, and digital farming solutions to help farmers support their daily work on the field. And my team is global geospatial data engineering team that helps in on this. And today, I would like to talk a bit about what our team is focused on daily basis and help you understand what it takes to manage agriculture from space. But maybe let's start from a question. What do you have in mind if you imagine 1 million hectares of farmland? Try to imagine that. Maybe a vast landscape, fields stretching all the way to the horizon. Tractor, somewhere out there looking very small, right? And now imagine that these fields are located in more than one country, more in one time zone, and across different continents, growing different crops, and changing every single day. Rain falls in Brazil, like today in Warsaw. Heat wave hits southern Italy, and at the same time, pest outbreaks start in India. This is our reality at Bayer Crop Science. And the most practical way of seeing so many things at this scale is from above. So satellites orbiting hundreds of kilometers above the Earth help us observe what is happening on the ground without even being on the ground. But today, I don't want to talk only about images from space, unless I know they are beautiful very often. I want to talk about what sits behind the decisions that are made on the field, about data engineering pipelines, platforms, and people that turn raw measurements into insights that people can really use. But maybe let's firstly clear up what this satellite imagery is, because maybe it's not obvious for everyone. So most of the people usually think about it like about a picture taken from space. A picture, basically as we take by our iPhones, our smartphones. But in reality, this is only a small slice of what the Earth observation really is. A lot of the data is basically something that is beyond what our human eye can really see. A lot of the information is captured during the whole spectrum. Satellite measure surface reflectance across many wavelength bands. And for example, the near infrared is something where plants can see, can change their reflectance. And I will show you this on the other slide. But many of the satellites capture data in many wavelength bands, and they are called multispectral, and also increasingly hyperspectral, where each spectral channel is designed to measure the light, the surface reflectance, in a specific range of the wavelength. So, but this is also important, and also, maybe I can also go back. Here you can see an example of Sentinel-2 that belongs to Copernicus mission from European Space Agency. And here you can see the bands are located across the whole spectrum, and we have 12 of them. And why this matters? Because in soil, water, and vegetation, the light behaves, the reflectance behaves in a totally different way. And healthy vegetation reflects strongly in near infrared. And this is what it's possible to monitor plant health, biomass, water stress, long before the human eye can really see that. And of course, I was only talking about the optical imagery. But besides that, we also have a radar sensors that work during the day or are visible through clouds. And also thermal that can measure surface temperature. So that's important to understand that there are multiple sensors, and each of them can help us solving different questions. Here we have also example of an optical satellite imagery. On the left side, you can see a visible light, a mix of red, green, and blue bands. And on the right side, we have the same imagery, but in false color, a mix of red and near-infrared colors. And you can clearly see this is a vegetation index where the vegetation is exposed better than on this visual image. And also, there is a hard physical truth. Clouds block the visibility. Also, haze and shadows distort reflectance. So sometimes when a person asks us to deliver imagery, satellite imagery from a specific date, from a specific field, like, for example, today from Warsaw, the answer will be, we will not have the image because of the heavy rain, right? Because the clouds cover the whole sky. And many users don't realize that satellite data is not one size fits all. You rarely get high resolution, high frequency, and global coverage all at the same time. So the important thing that you have to understand is to have the combination that is sufficient for your use case. Because, of course, there are multiple data sources that are free to use from public data providers, but we also have very expensive products provided by private providers. And also, they are very expensive per square kilometer. And on the other side, the cloud storage at petabyte or like thousands of terabyte scale is not free either. So before any data pipeline runs, there is a real product question. What is your use case, right? And also, the question that actually matters when someone says, I need satellite imagery, is not the only which area you want to have the image taken of. You also need to ask a question about which sensor is useful for your analysis. Is this visible light? Is this multispectral product? Maybe thermal or radar? Which spectral bands are useful for your analysis? Maybe a visible light is enough. Maybe you need infrared bands. What spatial resolution is sufficient? Is 10 meters per pixel enough? Maybe 3 meters per pixel, or maybe 50 centimeters, because when we have small fields, we need to have like a much higher resolution to see more. And also, what revisit frequency? So do you need imagery available every day, or maybe once per week is enough, or maybe once per month? And over what time range? So for some cases, we need a long archive of imagery, because maybe people want to get a time series, maybe they work on forecasts, or maybe only data during the season is important because we just want to have a monitoring. So, but now I would like to show you 3 examples, 3 use cases from agricultural world to show you how these products are used. So first example, first use case is in-season crop monitoring. So let's say we have an agronomist working with a grower in a cornfield in, let's say, Nebraska, US. The field is hundreds of hectares big. And the information that they are interested to get is about each square kilometer, a square meter of the field, if everything performs as they expected. So here, when we want to use satellite imagery to help them to answer these questions, has to be frequent and consistent revisit, and with medium resolution, and captured during the whole growing season, showing the vegetation index that represents the value of the vegetation. So when the pixel value drops, the agronomer understands that something happened on the field, and he immediately knows where exactly he should go and verify the change. And here we have the operational decision that can be made. Do we walk to the field? Where exactly? Do we need to adjust irrigation? Or maybe we want to change a recommendation for farmer. That's something very commonly used in agriculture. And now let's move to a research breeding station where we have the same crop, but instead of one big cornfield, we have thousands of small experimental plots, each few meters wide, each with different genotype, different hybrids, different type of seeds that we test. So here, the requirement flips. We no more need have very frequent revisit. But on the other side, we have very high spatial resolution. We have small fields, so pixel has to be smaller. And we also need exact geolocation accuracy, because if one plot and pixel bleeds into another, then we get a wrong result of the analysis. And this is something that we don't want to have. So here, the decision that our breeders, our data scientists can make is about which genotype, which product, which hybrid performs better in these specific conditions. And then we know which type of seeds can be delivered for people growing corn, for example, in this specific climate and region. And now the most human example. So in different regions in India, agricultural insurance programs are designed to protect smallholder farmers, to help them with droughts, other extreme weather conditions, or pests and diseases. And when it happens, they need to fill insurance claims. And usually the process has been very slow and painful. And now, when we have a satellite imagery that can help them, and derived products like soil moisture data, for example, that is a derived product from optical and radar imagery, they have something that runs as a backup together with what is happening on the field. So when something happens, they no longer only rely on the manual visit of an inspector on the field, because they have an evidence that can help them get the money. So get the money after the bad season. So the decision here is big. So here we learn that the satellite data is not only a product that is used by data specialists, data analysts sitting in the office. It really helps families to overcome a bad season around the globe. It's because it's not only in India. So what we learn from this? We learn from this that we have 3 different use cases, 3 different products, 3 different pipelines. And in normal world, we would have 3 different teams working on these solutions and delivering products to different organizations or end users. But in our case, we want to put everything into one platform and deliver it to people in the same conditions. So each time someone needs a product for themselves, they can use the same underlying layer. And here I would like to also tell you that in a large organization, the hardest part is not just getting one image. It's not just downloading an image from the internet, where some of them are free to use. But it's to create pipelines and data discoverable, reproducible, governed, and scalable across many teams, and of course globally, and different use cases. So here I would like to walk through the workflow that we usually follow when we try to solve these issues for people. So first step is sensing and sourcing. So it starts with deciding where the data comes from. As I mentioned, there are different providers, different data sources. We have public missions like Sentinel and Landsat that provide global multispectral imagery available almost every day. But on the other side, we have also private vendors that have specialized sensors and even higher spatial resolution. So each of them provide data in multiple formats and also multiple projection. They have various licensing terms and also different cost models. So here, the first step is already a big work that has to be done before any pipeline starts running. And just normalizing this into something that is consistent for every team is a real piece of work. And then we have acquiring and entitlements. So we already know which product we want to use. Now we want to understand what's the area that we are interested in. So what's the field boundary? And also who is allowed to acquire what, under which contract, with which quota. So how do we make sure that the right teams have access to the appropriate data, and how we prevent sharing everything to everyone? Of course, we need to understand that there are different data privacy rules. Vendors have their own licensing terms. So we need to be compliant. And also, as you already know, we work globally. So each country also has their own rules. So this is the moment when we realize that in a large organization, entitlements is not a nice-to-have thing. It's a crucial step that we need to keep in mind to stay on the right side of the compliance. Then we have the ingest and quality assurance. So normally, once data arrives, the first thought is to just publish everything what we just bought. But the important thing is to publish only what's useful for our end users. And this step includes clouds and shadow filtering, and also flagging invalid scenes, enriching metadata so assets are searchable and reproducible. And also, we need to understand what are the steps happening during the pipeline and surfacing them to our end users, so they know if the image that they ordered is in pending status, if it has been already delivered, or maybe it failed. So it has to fail visibly so they understand what to do next and why they cannot get this image. Now we have catalog and serve. Here is the step when our data becomes a product. Product that is cataloged in a way that every end user is able to get it in the same way. So here we have imagery assets and properties attached to them, like what is the sensing date, what is the sensor, what's the spatial resolution, which bands have been captured. So the image enriched by additional metadata informations, so it's easily accessible for people and understandable, and they can order what they want through a consistent API. And for example, Stack, a spatio-temporal asset catalog specification, is for geospatial world a common way to catalog and store this type of data, Earth observation data. And in our organization, we handle daily hundreds of millions of requests per day. So we also need to focus on caching, query optimization, indexing, and multi-region handling. So that's already a lot that we have to do in this step. And also, the important piece here is that people should just get what they want without needing to understand what happened before. And now we have a decision layer. It's when our end users get the data from us. But usually, it's never a just raw image. They want a map layer, they want a metric, they want an alert, they want this field is fine, or this field needs attention information. So the pipeline doesn't stop at storage. It stops when an agronomer, maybe data scientist, or breeder, or supply team understands what they get, and when they do not have to become a remote sensing specialist, They just get the answer that they asked for. And the last sentence is actually the goal of the whole stack. We want to do the job for them, so they are focused only on what matters to them. So over the past decade, the situation related to the Earth observation has changed dramatically. Currently, we have satellite imagery covering the whole globe, nearly every square meter, every day, even more than once per day. So this is something that data scientists couldn't imagine even a few years ago. So today, resolutions keep improving. AI-based products like field boundaries detection, crop type maps, biomass estimates built on the top of satellite imagery help us better understand the world. But on the other side, we have more providers, more data formats, more access patterns, all happening at the same time in parallel. So it's important here, I want to leave you with the thought that not only data, not only images are important, but better systems that handle this data. So stronger enterprise access and cost management. This is very important when we use data from different providers, different vendors. And absorbing new sensors, clean separation between raw measurements and derived products, and operational maturity. So when something fails, it fails visibly. And people that use our pipelines understand that we are reliable, they can trust us, they can trust the value of each pixel, and they can use it on field. And here's the thing I would like to leave you with. Seeing from space, again, it's not about images. It's about trustable measurements delivered through systems that are repeatable, governed, and understandable. And this is what it really takes to manage agriculture from space. Thank you.